This is geometry class, unit 10, day number 3. This is the volume of pyramids and cones. What we've been talking about is that a pyramid is going to be 1/3 the total volume of your prism. So if you have the same base and the same height, you're going to be 1/3 the volume of the prism that has the same base and height. So the volume of our pyramid is going to be 1/3 capital B, which stands for the area of the base, times the height. So we come over here to our first question, and we notice that the volume of a regular pyramid, if it's a regular pyramid, you'll notice they show the 90 degrees in the corner and all the sides are the same. So that's implying that this is going to be a square. So each side is 14. So we're first going to find the area of the base. So the capital B is the area of the base, which is 14 on one side and 14 on the other. That's 196. So if we're going to do the volume, which is 1/3 base times height, the volume is going to be 1/3, not 1/2, but 1/3. The base is 196, and the height, notice they're pointing to perpendicular. Perpendicular has to be 90 degrees straight up and down from your point of your pyramid down to the base, not along the side, not the slant height. So this is 10. And when we do our calculation, using our calculator, we get 653. Nice. We're going to round to the nearest hundredth. So these are meters cubed. You notice that the units in the picture talk about meters. So what this is implying is that there would be 653 square blocks. If these were meters, these square blocks that would be inside of this pyramid. Now, what do you notice to be different about letter B? Okay, they're giving us the 13, which is the length of the slant, all right? And we know that the slant portion is going to be longer than a perpendicular portion. Okay, so if you think about it, if you went straight up and down, that would be shorter than if you went slanted. The slanted is your 13. Now, if it's 10 all the way across, and you were to drop down that middle portion, what would be the short side of this triangle? It's going to be half of your side length. Very good. And if you know your Pythagorean triple, does anyone recognize which Pythagorean triple this one might be? 5 for one side. What's the missing side if this one's 13? Anyone familiar with that Pythagorean triple? If not, then we need to do hypotenuse squared equals leg squared plus, we'll call that h. So h squared, that's 169 equals 25 plus h squared. When you subtract the 25, you get 144. So now, how about that? Anyone know what the square root of 144 is? Nice. So that was the number we could have recognized as our Pythagorean triple. 5, 12, 13 is a very common Pythagorean triple. So now we know what the height is. So we can go back to the volume equals 1/3. The base is 10 squared because that would be the area of the base would be 10 squared times the height we calculated to be 12. That's where we do not use the slant height. All right, and when we calculate this out, we get 400 centimeters cubed. 100 times 12 is 1,200, and we're doing 1/3 of that. 3 goes into 1,200, 400 times. So the volume is 400 cubic centimeters. So that means there are 400 square blocks that would fit inside of this pyramid. All right, there is a pyramid in Mexico. It is a square-based pyramid with a height of 63 meters. The volume is 970,725. What is the length of the base? Correct, we are. We're going to work backwards. So we have our square base, and those are the two dimensions that we don't know. And then this is going to come up to a point to be our pyramid. We know that this height is 63 to the top and bottom of our pyramid. So we have the volume to be 1/3, the base times the height. What we don't know, we don't know what our base is. So our volume is 970,725. That's going to equal 1/3. Our base is x times x, so that is x squared. And our height is 63. So I'm still plugging in my values into our formula. And notice in this case that they're giving us the value of the volume. So we need to plug that number in for V. Some of you had troubles with that on the last quiz. You just took what the total area was and you used that as a radius, but you needed to plug that in for the area of the circle. So in this case, we need to plug this in for the volume of the pyramid. All right, so what we have here, we have a couple different choices. You could take 1/3 of the 63 if you wanted to. All right, that would leave us at 21. So we have 21x squared. And then we could divide by the 21. I use my 1/3 of the 63.
Oh yeah, I see.
So that's going to give us 46,225. Yep. Nice job. So our area of the base is 46,225, but we are looking for the length of each side of the base. So what do we going to need to do with this? Take the square root of both sides. Yes, it is. 215 meters. Now this is not meters cubed because this is just one length of the pyramid. This is not the total volume of the pyramid. The total volume was that huge number, 970,000. This is one length of the base, one measurement of the pyramid. So it's just meters. Just like the pyramid is 1/3 a prism, a cone, and we'll watch a video on this afternoon, a cone is 1/3 the volume of the entire cylinder. The cylinder would come straight up, would round out, and you apparently could fit 2 more cylinders in there. You could fit one more along one side and another one along another side, and that would make 3 of those cones can fit inside of a cylinder. You probably have to do some pushing and crunching to get it all to fit, but it would all fit in there. So the capital B in this case, we know what this base is. All right. We know this base is a circle. So even though we say 1/3 capital BH, it's really 1/3 pi r squared, because a circle is always pi r squared. So the capital B in this case is the area of a circle. And the H is your height, where the R is the radius. So a cone is always going to have a circle for a base, and it's always going to move up to a point at the top. Again, we're going to need to know the height, which is perpendicular from that vertex point, not the slant height. If you're given a slant height, then you need to use Pythagorean theorem to figure out what your actual height is. So here we have a couple to work with. We're going to find the volume of the cones. Notice with this cone, they're giving us the actual height of the cylinder, actually of a cone. This is the height of the cone. You got to be sure that the arrow is pointing to that, where it might be a little bit different as we look at letter B. They're not pointing to the middle. They're saying that the side slant height is 9, but this one is 16. So we're ready to say volume equals 1/3 pi r squared times the height. We can calculate that by plugging in our radius, which they clearly give us is 10, and our height is 16. So we will square our 10, not moving anything. And that gets us 100. 10 squared is 100, times 16 is 1600. And when we divide that by a 3 and times it by a pi, the volume is 1,675.5 meters cubed. You should practice typing that into your calculator to be sure that you understand how that works. As we look at our second question, we notice the 9 is the slant height. Very good. And the slant height is not considered the height of the cone. That would be considered the hypotenuse of a triangle that could be framed out inside of our cone. So if you notice from the center of the circle to the edge of the circle is 4. And what we don't know is what the height of this is. Sure. Notice how A has an arrow that points to that middle location. And if you notice, B does not have an arrow that's pointing to that middle location. That B, the 9, is sitting out next to that slant height without any indication that I actually belong somewhere else. This here, maybe they would have tried to cram it in there tight, but they used an arrow pointing to it. Similarly to how they did with letter C, they pointed to where the 25 goes. There was no additional pointing, so that implies that it stays there with the slant height. Great question. So now we're going to say that the hypotenuse squared equals the height squared plus 4 squared. 9 squared is 81. Let's see, I lost my equal sign there. And 4 squared is 16. And we do this and we get, that'd be 71 minus 6 more is 65. So our h squared is going to equal 65. So to figure out which is h is the square root of 65. And 65 is not made up of any perfect squares. So we cannot simplify that any further. So we're ready to head into our formula. 1/3 pi, the r, pi r squared times the height. Square root of 65. So to show what this would look like as we type it in, I like to use parentheses around our fraction. So we're 1 divided by 3. So that's our 1/3. And we're timesing that to the pi. We're going to times that to the 4 that's being squared. And we're timesing that to the square root of 65. So we can type this in a straight line, all into our calculator to get a rounded value. So our volume is going to be approximately 135.08. These are feet, and it is cubed.
Hold on. I don't believe that was like what I got. I thought it was 135.05. Never mind.
So notice how we had to figure out the height first, and then we're able to plug it into our formula.
And now we don't even know the height, the slant height or the radius.
We don't know what the radius is, correct? We don't know what the slant height is, because with the height, we could do Pythagorean theorem, but they give us this funny 70-degree thing. What is that 70 degrees going to be? What are we going to use that 70 degrees for? Any suggestions? We can use opposite. Now, if we were looking for the slant height, opposite over hypotenuse, this is going to be opposite and adjacent tangent. So we're going to do tangent of 70 equals the opposite side over the radius. And since our variable is on the bottom, we need to cross multiply. So that's going to give us the radius times the tangent of 70 equals 25. Now you're thinking about what you need to do here. What's going to be our next step? Do we just go to the calculator? Do we have to do another calculation? We're going to divide tangent of 70 to both sides. So the radius equals 25 divided by the tangent of 70. You need to be sure you are in degree mode because you're typing in a 70, which is a degree. It's possible your calculator was in radian mode. If you're not sure which mode that you're in, this looks like it would be rounded to 9.10. If you're not sure which mode that you're in, you can do sine of 30 degrees and you should get 0.5. But now since we know what the radius is, the volume equals 1/3 pi 9.1 squared times the height. And remember, they gave us the height of 25. So we have 1 divided by 3. That's the 1/3 times pi times 9.1, or you could even use the answer button in your calculator. Would love that. Squared times 25. So I typed it all in on one line. That gives us 2,167.96. And this is volume, so we're going to have centimeters cubed. You want to be sure you have your units correct. Couple more questions here. Now with the next one, you notice that they're showing us what the volume is and they're using the pi symbol in it. That makes calculating for different parts a lot easier. And we're trying to solve for the height. So we apparently, okay, I draw my cones by starting with the slanted portions. We have the rounded base, and then you can do the dashes behind it to kind of show the rest of your cone. So there's our cone. We know that the radius off to the edge is 18. What we don't know is what this height is. The height is the unknown. So using our formula, the more times you write it, the more familiar you'll be with it. So volume equals 1/3 pi r squared times the height. We know what the volume is, 1,350 pi. Don't forget the pi. Equals. This is helping us have a very clean answer. Our radius was 18, and we need to square that times our height. So there's a couple different things we could do here. We've got this 1/3. We don't typically divide by a fraction, but you could multiply by the denominator. You could multiply the 3 to the 1,350. That would be a possibility. You could square out 18.
That's 324.
Nice job. So you could call that 324. And you could divide that one by 3 or multiply that by 1/3. And you could cut that in half. So you, not half, but into a third. You do have some options in terms of how you can handle that math calculation. So I chose to take 1/3 of the 324. So I've used the 1/3, I've used the 324, that's where the 108 comes from. Now I can divide by both the 108 and the pi at the same time. And over here, divide by the 108 and the pi at the same time. And look at what happens. The pi's cross out. I won't have to have decimals. That's the advantage of putting pi with the volume. So you don't have to have the decimals that are associated with calculating with pi. So we have 1,350 divided by 108. That gives us 12.5. Relatively clean answer. So these are in meters. It's not meters cubed, because it's just a height, it's a length, it's a measurement of your cone. Moving towards some more of Cavalieri's principle that we have talked about before. Here, this shape is a bit slanted, all right? But still, what we're going to need to know is your perpendicular height. That is all that you need to know. So they're implying here that the 2.7 is the perpendicular height, the straight up height. So again, the volume equals 1/3 pi r squared times the height. So the volume equals 1/3. The radius is 1.1 squared times our height of 2.7. So you want to be sure to type out or write out your entire formula and then plug your numbers into your formula. Then you can take your calculator. I use the parentheses and I do 1 divided by 3, because that's 1/3. And I'm timesing it to pi. And I'm timesing it to the 1.1 squared. And I'm timesing it to the 2.7. So you can write that in a complete line in your calculation, and that will come up to be 3.42. 3.42 centimeters cubed. This is volume. So volume is cubed, area is squared, length is to the first power.
Now let's see how big triangle or pyramid or solid I want to say.
So what do we figure we need to do for this next one? Find the area of the base, and your base is going to be down here. And the trickiest part when working with the triangle is that you need to have the base times the height of the triangle. You need to have perpendicular sides of the triangle, and they imply that we have that. So our volume is going to be 1/3 BH. Well, in the past, when we were working with a cone, the B is a circle, so it's always pi r squared. But this B is a triangle. So this B is going to be half the base times the height, the 6 times the 8. And then we times it by the height from perpendicular to that base. You could type that whole thing into your calculator if you wanted to, but 6 times 8 is 48. You can take half of that 48 to get 24. You can take 1/3 of that 24, and that is 8. So your volume is going to be 24 feet cubed. So notice what we did. We had to find the area of the base. And in this base was a triangle. So we had to do the area of a triangle, which is half a base times height. And then we continued with the volume, which is 1/3 that base times the height. Last question. So we're making coffee apparently using a cone-shaped filter. It takes 14 minutes to brew an amount of coffee that would be equal to the volume of the filter. So we're going to take the filter and we are going to essentially like drain out that filter. Find the flow rate in cubic inches per minute. So the first thing we're going to find out is what the volume is. The volume is 1/3 pi r squared times the height. Well, they give us all the needed numbers. They tell us that the radius is 3, so we need to square that. And they tell us the height is 3.5. We can plug that in. If we plug this all into our calculator, like I've shown you several times, we get a value that's very close to 33, but it still rounds to 32.99. So next, we're going to talk about a flow rate. Our flow rate is going to be the volume divided by the time to filter, the time to drain that filter out. So what we have as a flow rate is that 32.99, and they said that it took 14 minutes to drain that. So here we have the cubic inches, and now we're going to do the cubic inches per minute. Look here at what they told us. Find the flow rate of cubic inches per minute. So you want cubic inches on top, per, which is your fraction, and minutes on bottom. So that's helping you understand what your units are at the end. So we find out that the flow rate is going to be 2.36 inches cubed per minute. So it drips out what would be equivalent to the 2.36 cubic inches every minute.
Not too long this time.